So this lesson is going to be factoring by greatest common factors, which we happen to also sometimes call GCF. In order to find the GCF of numbers, what you're looking for is the largest number that divides evenly into all of the numbers. So the largest number that divides evenly into all of the numbers. In terms of the variables, it's interesting because even though we call it GCF, in terms of the variables, we're looking for the smallest power, not the greatest, but the smallest power of all common variables. So the smallest power of all common variables. The reason why we're looking for the smallest power is because we have to be able to divide it out. So you can only divide out the smallest number from everything, not the largest, because not everything will have that amount. So here's what we mean by that. Between the 12, the 48, and the 36, the largest number that divides evenly into all three of those numbers happens to be 12. And in terms of the variables, I've got x to the second, x to the first, and x cubed. Well, the most amount of x's I can divide out evenly from all of them would just be x to the first, because I can't take out x cubed if I only have x to the first power. So I'm looking for the smallest power of whatever's common in terms of the variables. There's your GCF there. On this guy, your GCF. In terms of the numbers, the largest number that can divide out evenly from 18 and 24 is a 6. In terms of the variables, I've got a squared here on both of them, which means I can divide a squared out of both. I've got b to the first here and b to the second there, so b is common, but the most I can take out is just b to the first. And the fact that I've got a c on the right but not on the left, I can't pull out c as a common factor. So the GCF is just 6a squared b. When we start factoring by GCF, we're going to find the GCF of the entire polynomial, and then you're going to divide all the terms of the polynomial by the GCF. It's what we did in the lesson yesterday, and it's also just like reverse distribution. And you can always check your answer by using the distributed property, because if you distribute the outside into the parentheses, you should end up with your original. All problems when factored by GCF always have the same final look. It's going to be GCF outside of some other polynomial inside of parentheses. So for the first one, the GCF of the numbers is 9. The smallest power of x is x to the first. So I'm going to pull out 9x. And then I have to open up a parenthesis. And I say, well, what's going to get me back to the original? It's basically like division. If I divide 9x out of both of these terms, I'm going to get 9x squared divided by 9x is x, plus 36x divided by 9x is 4. This should be your final answer. The reason why I know that it's true is if I wanted to check this, not that you have to show it, but if I wanted to check it by distribution, I would multiply 9x through the parentheses, I would end up with this, and that's what I had started out with to begin with. So that's why I know I'm right. On the next one, in terms of GCF, there's no numbers of a GCF other than a 1. Essentially, this is a 1 right here, but between 15 and 1, all you can pull out is a 1. In terms of variables, the y's are common to both. The smallest power of y is y cubed. So my GCF becomes y to the third outside of a parenthesis. How am I going to get from y cubed back to my original problem? Well, y cubed times 15x is 15xy cubed. And y cubed times negative y is negative y to the fourth. I didn't show it as division this time. I just did it as reverse distribution. Either way is totally fine. On the next one, in terms of my GCF of numbers, 12, 20, and 32, everything is divisible by a 4. That's my greatest common factor. They all share an x, but the smallest power of x is x squared. Here I am going to show you the division. So what's going to happen here is I'm going to open up my parentheses. So 4x squared is my GCF. When I open up the parentheses and I do my division, what's left over becomes 3x to the third minus 5 plus 8x squared. You need to understand that if you factored correctly, there's going to be no more common factors inside your parentheses. So that's maybe worth writing. If you factored correctly, there will be no more common factors inside the parentheses. So what's happening here, what I mean by that, is if I were to look inside this parenthesis, there are no more GCFs anywhere. Okay, so your final answer then is the 4x squared with the parenthesis 3x cubed minus 5 plus 8x squared. Last one. In terms of the numbers, I'm going to be able to pull out a 7. The smallest power of a that's common is a squared. The smallest power of b that's common is b. So 7a squared b outside of a parenthesis. How do I get back to the beginning? I need to multiply by 4b squared to get 28a squared b cubed. Then you need to multiply by positive 3 because that gets you 21a squared b. And then you're going to multiply by negative 2ab because that gets you back to negative 14a cubed b squared. And that is it.